In this example, we're given this piecewise function and we want to find where it's discontinuous. So I'm going to do this just by looking at the equations given. Alternatively, you can always graph this function as well to try and help you get a better sense. But if we just look at the equations, the first step is to look at each function separately that we piece together and see if it has any discontinuities itself. So if we just look at x cubed on its own, that's just a cubic, that's a polynomial, that's continuous for all real numbers. Okay, same thing's going to happen with x plus 6, that's just a line, and 2x, there's another line. These are all continuous for all real numbers. Where do we run into an issue? The rational function at the bottom, negative 20 over x minus 6. Okay, so that is not continuous for all real r. We have a discontinuity there when the denominator is 0, so it's discontinuous when x is 6. Okay, once you find a discontinuity, then you now need to go back up to the piecewise function and see when x is 6, is that even part of the domain, or is that even part of where this function is defined in the piecewise function? So when x is 6, 6 is greater than 4, so that is part of the definition of this function, which is telling me that I know I'm going to have a discontinuity, I'm going to have a problem when x is equal to 6. That's one of the spots. Alright, now the next thing that we want to check is all the places that we piece together these functions, all the boundary points, because there's the other potential area where we might have a discontinuity. So let's look at one of the first boundary points. The first place I see this happening is at 2. It's a boundary between the top two functions. Okay, and remember from the definition in class, in order to be continuous at x equals 2, we need the limit as x approaches 2 of the function to be equal to the value of the function at 2. So what is g of 2? When x is equal to 2, we're going to be here on the second function, x plus 6. And so g of 2 is just going to be 8. Okay, but now we also need to check the limit. So let's look from the left and the right. So we'll do the limit as x approaches 2 from the right. In that case, when we're coming in from the right, we'll have numbers that are bigger than 2, so we're going to be, again, on the second function, x plus 6. And so that limit is also going to give us 8. And finally, we need to check from the left. And from the left, those are going to be values that are less than 2. So that's going to put us under the top function, the x cubed function. Okay, when we evaluate that limit, we can just do it by direct substitution. We also get 8. So since the limit from the left and the right are the same, this tells us that the overall limit, as x approaches 2, of g of x is going to be equal to 8. And then finally we check to make sure, and that is the exact same as the value of the function at 2. So this tells us that the function is continuous when x is 2. I don't have a discontinuity there. Okay, now we need to check another boundary spot. So what's the next boundary spot where we piece things together? It's happening at 4. We're going to do the same thing now at x equal to 4. Okay, so let's start. We're going to do the same three things. Let's start this time with the limit. So let's look at the limit as x approaches 4 from the right. So if I'm coming in from the right, I have numbers that are slightly bigger than 4. It's going to put me on the bottom function, or that rational equation. Okay, when x is 4, I can just evaluate this by direct substitution. So I'm getting negative 20 over negative 2, so I get that that limit is 10 coming in from the right. Now we'll look at the limit from the left. Okay, as I'm coming in from the left, so now we have numbers that are slightly less than 4. That's going to put me back up on the line x plus 6, because that is for values of x that are slightly less than 4. When we plug in 4 to that, we get 10. So we do get the limit exists. This tells me that the limit exists and it's equal to 10. But now in order to be continuous at that point, we also need to see what the value of the function is at 4. So what is g of 4? So when x is exactly equal to 4, that puts me here. That puts me at 2 times x. So that tells me that g of 4 is 2 times 4, which is equal to 8. Okay, so since 8 is not equal to 10, we know that this function is not continuous when x is 4. So I have another discontinuity when x is equal to 4. Alright, and I've checked all the spaces or all the possible places where I could have a discontinuity. So these are my final answers. Those are the 2 places where the function's discontinuous.